Example 1. Find GFX. GFX means you substitute f into g. So we can write as g bracket fx or just gfx. Okay, how are we going to do this one? Now, firstly, think about gfx means you replace the x by fx. Okay, so that means it used to be x squared, now become fx squared plus 3. Okay, so it's like previously inside the bracket is x, but now we erase the x because now we put in the fx. Okay, now after that we substitute fx in, simplify if possible. Okay, so this is gfx. The same as the next one, gfx. Okay, means 1 over used to be x, now become fx. And fx is sin x. So it's 1 over sin x. 1 over sin x also equal to cosecant x. Okay, next one. This one also asks you to state the domain. So f gx means the 2x become 2 times gx. Okay, so once again, x replaced by gx, g sub into f. And then that will be 2 times x squared plus 3, which is 2x squared plus 6. And then we need to look at what are the domain for gx. Now, basically for gx, x can be any real number. Okay, x can be any real number. And then when you sub gx into fx, if fx also, no matter what you substitute in, you always can get the value because it's a linear function. So no matter what x is, minus, positive, 0, x sub into g, you always get the value of g. And then whatever value g that take sub into f also have a value. That's why the domain for A is any real number. Okay, usually for linear function and quadratic function, their domain are any real number. Second one. Fgx is sin 1 over x. Now for this one, we must know, firstly, 1 over x is undefined if x equals 0. Okay, so to have the value for 1 over x can be any number except 0. Okay, and after that, when you substitute the value into the sin function, if you remember, the sin function goes along the x-axis. Okay, goes along the x-axis. So if you want to substitute the value into a sin function, it can be any real number. Okay, for any real number of the angle size, there's always a sin value. Okay, so this one you don't need to worry about the sin function is undefined. You just need to think about how to make sure 1 over x is not undefined. Okay, so in order for 1 over x to be defined, x just cannot be 0. So this is the domain for the second one. Next one, f bracket gx is f 4 minus x squared x4 minus x squared has to be at least 0. Okay, so generally, square root of fx is defined when fx, the part under the square root, is non-negative. So now, since 4 minus x squared is under the square root, we have to make sure 4 minus x squared is non-negative. So to find this one, to solve this one, usually we use the quadratic graph to help us. Okay, there are two roots. And this one, since it's a negative x squared, we know the curve is opening downwards. And then back to our inequality, we're looking for the region, the value of x, that make this quadratic positive, and that should be the part above the x-axis. Okay, so 4 minus x squared is more than 0. That is when the graph of 4 minus x squared lies above x-axis. Therefore, in order to have that, x must be in between -2 and 2. Also, 4 minus x squared can be equal to 0, since the root of 0 is 0. So finally, the domain is -2 less than equal to x less than equal to 2. Now, if you look at these three questions, you can see the only few things we need to worry about when the calculation might be undefined. Firstly, if it involves a fraction, you have to make sure the denominator is not 0. Okay, if it's a fraction involved, make sure the denominator is not 0. So that will be the domain. And if you got square root in the function, whatever under the square root has to be non-negative. So that will also be the domain. Okay, this time not only we find the domain, but we also find the range. Domain is the value of x that make the function defined. Range of function is the y values that the function can produce. Okay, the question asks for gf, which means we sub f into g. So g is a sine function, and fx is 2x, so we get sine 2x. Okay, so let's think about what are the possible value of x and what are the possible value of y. Firstly, for fx equals 2x, x can be any real number. And then fx times 2 is also any real number. When I substitute f into g, the sine value, the sine function can take any real number. That's no problem. Okay, as we show in the previous graph, the angle size that you can substitute into the sine function is any real number. Okay, so in this case, the domain is any real number. And then let's look at the range. Now there's a range for sine 2x. The sine 2x, just like the other sine function, is always in between -1 and 1. Therefore, the range of the function should be from -1 and 1. Okay. Now here we need to take note of one thing. There are a few possibilities. For example, if I want to get g fx, that means I sub x into fx, and then I sub fx into g function. Okay, so firstly, if the range of f, okay, if the range of f is no greater than the domain of g, okay, if the range of f is not bigger than the domain of J, then no problem. Okay, like in our previous question, fx is 2x, the range is any real number. And then G is a sine function. For sine function, the domain is also any real number. In this case, the range of f is exactly same as the domain of G. So you can just sub any value you want. So that will be no problem. Unless the domain of G, the one that you can sub into G, is smaller than the range of f. That means some of the value you can substitute, but some of the f value will give you undefined. In that case, we need to adjust the value of f that can sub into the G. Okay, we'll see this in some other questions. Part B, GFX. Now I have shown you a few examples of finding GF. So here I just go a bit faster. Logarithm of x to the base e is ln x. Sub minus x into, so you got ln negative x. Okay, now this is a part that we need to be very careful. Firstly, for this one, x supposed to be any real number, and then the f is also any real number. But when we sub the value into the ln function, we have to make sure ln x is positive. Okay, so this one is something else. Generally, there are three cases that could make a function undefined. Just now, I already mentioned 1 over x. Okay, let's put it more general. The first situation is if a function over the other function, this is undefined when gx equals 0. So in this case, gx has to be not equal to 0. The second case, square root of gx is undefined when gx is less than 0. So in this case, in order for the square root to be defined, gx has to be more than and equal to 0. Number 3. Okay, this one is a bit special. If f over the square root of g, this one is undefined when gx is less than 0, so no root, or gx is equal to 0, then the denominator becomes 0. Okay, so in this case, gx not only more than or equal to 0, but to be more than 0. The last one, if you have logarithm of fx, this one will be undefined when fx is less or equal to 0. So for logarithm function, no matter what base is, to make it defined, fx has to be more than 0. Okay, take note of this. You may pause the video, then taking down the notes, or you take a photo of what I'm writing here. Okay, this is very important for finding the domain. Okay, so back to here. Therefore, for the ln function to be defined, minus x has to be more than 0, which means x must be less than 0. Okay, so for part B, x is not any real number, because if x is any real number, f is any real number, I cannot guarantee there's a log value. So x must be less than 0. So the f, which is negative x, is more than 0. Okay, so this is a domain. And then when it comes to the range, when you look at the ln function can take any real number. Okay, so x is less than 0, y is any real number. So this is the case I mentioned here. Okay, so x is any real number, f is any real number, but then for g, it's only positive. So if you got f equals 5, sub into here, got long 5, no problem. F equals 1, got long 1, no problem. F equals 0, long 0, undefined. Then cannot, right? So what shall we do? We need to adjust the f. I cannot take all the f. Okay, I can only take x less than 0. So f is more than 0. Then the GEF can be defined. Okay, part C. So GEF 2 sine 1 over 2x. So in this case, once again, x cannot be 0. Okay, x cannot be 0, which is the domain. Sine function is in between 1 and -1. So 2 times that sine function is between -2 and 2. That's why the range is from -2 and 2. Okay, last one. GF is 1 over fx minus 1. Okay, so sometimes if you feel that the function is very hard to calculate the composite, just be careful, do step by step. So firstly, replace the x by f, and then sub into the f. Okay, in this case, the domain x cannot be 6. Okay, and then the range is y cannot be 0. Okay, so this one you may wonder, how do I know that this 1 over x minus 6 cannot be 0? This is due to the fact of the rational function, because 1 over x minus 6, when x minus 6 is less than 0, the function will be less than 0. Okay, so when x minus 6 is more than 0, the function will be more than 0. So it can be any negative or positive value. But the function is equal to 0, the fraction is equal to 0, only when the numerator, the top, is equal to 0. Unfortunately, here, the top, the numerator is number 1, is non-zero. So if I make this fraction equal to 0, I will get 1 equals 0, which is impossible. Okay, that's why if the numerator is a non-zero, the whole fraction will not be 0. So that is a range for this one.